Hey everyone, welcome to fifth part of my logistic regression tutorial series. So in this part we'll design a simple algorithm to distinguish cat images from dog images. So we will build a logistic regression using a neural networks mindset. So here is a figure which explains why logistic regression is actually a very simple neural network with one neuron. As you can see, all inputs goes to one neuron. It gives us an output of 0.73 and it's a cat. So in future tutorials you'll see how we will do this with several neurons and how we'll build our deep neural network and why logistic regression is quite similar to neural networks. So we can call it like a small neural network. So main steps to build a small one neural network. So we'll define steps which we'll use to build a neural network. So at first we'll define the model structure. It's a data shape. So we already did that in our previous tutorials. So next we'll initialize a model parameters. So we'll do this, but not in this tutorial. We'll do this later. And then we'll learn the parameters for model by minimizing a cost. So this step will be separated in three different steps. So we'll calculate current loss, calculate current gradient, and update parameters. So we'll do a forward backward propagation and then gradient descent. So in this tutorial I will do only on forward and backward propagation, and you'll see that it's quite simple, but you must know how it's done and why it's done like that. So next we'll use the learned parameters to make predictions on our test set, which I already have, and we'll analyze our results and conclude our tutorial. So this is all steps we'll do, and right now I'll going back to my code, and this is my fourth tutorial part code, and I'll comment a few lines I have here, and because I don't need it right now, and I have I'll copy a sigmoid function from our first tutorial where we created it, and I'll just paste it here, so we don't need to write it. So it's quite easy to write, but why we should do that if we don't need it? So at first I will talk about forward propagation. Let's begin with a theory side and then we'll go to practice. So forward propagation. So first, weights and bias values are propagated forward through the model to arrive at predicted output. So from here to here. At each neuron, the linear combination of the inputs is then multiplied by an activation function, so sigmoid function in our example. So in this process, weights and biases are propagated from inputs to outputs, and everything of this is called forward propagation. After arriving at the predicted output, the loss for the training example is calculated. So this is forward propagation, and how we do this, here's a few formulas, actually 5 formulas. So at first we calculate our z, then we do a sigmoid of our z, and then we calculate our loss, and final function for our loss is this. So this is a combined function of everything what is here. So don't worry if you don't understand, I'll write everything on my text tutorial, and I'll do everything in a code, and this will be much easier, and you'll see. But at first, if you would like to learn data science, you should learn to read formulas like this, the mathematical expressions and so on. So that's simple about forward propagation. Next is backward propagation. It is a process of calculating the partial derivatives from the loss function back to the inputs. So we are updating the values of w and b that lead us to the minimum. So it's helpful writing out the partial derivative starting from dA to see how to arrive at dw and db. So as before we did from left to right, right now we actually do same stuff from right to left. So actually there's a specific formulas from this, and we always have formulas according what we do in Fourier propagation. So it's good to know how it's done, but you don't need to remember that, because probably you won't need it. So mathematical expression of backward propagation is to these formulas. So here we get dw and here we get db. And don't worry if you don't understand. As I said before, we'll do everything in practice, so in code. And of course, I'll post it on my website. So I think it's fine with forward and backward propagation theory. And now we can continue on our code. And here, as I have sigmoid function right now I need to define a new function. So I'll write it as define a propagate. And here I'll use w, b, x, and I, just like that. And what we need to get at the end is return grads and cost. So you'll see what it is, but don't worry right now. So what is w? What will be our w? So w will be weights. So it's our numpy array of size rows, columns, and channels multiplied, all of them multiplied by 1. B is bias. X larger is our data set, so it's our reshaped images, so it's the same rows, columns, and channels multiplied and by number of examples. And I will be our true label of vector 0 if a dog and 1 if a cat. So don't worry, you'll see, everything will be more clear later. So at first we need to get a number of our examples. So what we do is we take it from x and we write shape and we take 1. So here is our number of examples, and right now we'll implement our function as before, and I can write it like this: is z equal to numpy dot, and here will be our w transposed by, and dot is by x plus b, and this is our tag 1. Let's show it to you. I'll minimize this a little. Sorry. So as you can see, it's almost the same. W transposed as it here, multiplied by x and plus bias. Same as here. Well, we need to use transpose because you see it can be multiplied like this. We need to have same shape. So that's simple. Okay, now we need to write a sigmoid. It's much easier than you think. And here we use a is equal to our function sigmoid from z. So this is our tag 2. And last is more difficult. So this will be our cost function. So we'll implement this one. So to be more easy with it, what we do is at the end there is everything multiplied divided by m, number of examples. So we can just write m divided by m, and here there was a minus and p sum, and then we write another functions, and here is there was a I multiplied by numpy log by a plus I minus 1 and this was multiplied by numpy.log 1 minus a 1 minus a and that's it. As you can see, it's log of 1 minus a, it's 1 minus I. Oh, I made a mistake, sorry. So so it was numpy 1 minus a I, and this was multiplied. Let's see right now how it looks like. Log a I multiply. So yeah, everything looks fine here, and that's it. We made our forward propagation function. And now, okay, I'll add this as tag file. And now we need to write a backward propagation function. So for this purpose, we'll write as it was there. It's dw and db. As here, dw, db. We won't write a dz because we'll implement it straight forward here. And let's write it. So it is dw is equal and db is equal to something. So here we write, it's quite simple, numpy dot multiplied by x, and here is, it's big X, not small x, sorry. And here is a minus I, and this should be transposed like that. And I think this was divided by m, and here will be a tag of 6. Yeah, it was divided by m, and as you can see, it was a minus I, as I wrote, everything transposed and multiplied by matrix multiplied by x, just like that. And we do similar to this function, and here is our numpy average function, and here is our a minus I, and here is a simple tag 7 function, just like that. And now we need to get a cost function. So cost will be equal to numpy squeeze. Numpy squeeze, how it writes, something like this. And we use squeeze because it is a numpy array right now here, and we need just a number, single number, so it gives us a number. And grads will use a dictionary for this. Okay, and here I'll write simply dw is dw, and just like that, db will be a db, and here is like that. So that's it. We wrote a full propagate function. So I commented this because we don't need it right now, so but later we'll need, but in this tutorial we don't need. And I'll comment these lines because it will slow us down, just like that. And now we can write some kind of example to test if our code works. So for example, if I write that dw is equal to numpy array something like 1 and another is 2, our bias will be equal to 4, for example. My x will be also a numpy array, so I'll just copy it to make it faster for us. It will also numpy array, but right now I'll add something more. I'll change a number, for example 5, 6 and -7, for example. I add dot because it will be a float number for us, and here will be 8, then it will be 9, and then it might be minus 10, for example. Okay, minus 10. And one more NumPy array. Let's add, this will be our I. So labels, and labels we simply we don't need this one. This will be 1 0 1. Yeah, I think it will be fine for our example. And now we need to call our function propagate. So like this, I take this and I write grads, and cost will be equal to propagate our inputs. Just like that, and simply let's print them out. So what we'll do here is we print our dictionary, grads, dw, and of course like that. Then we'll print our db and of course cost, just like that. And I think that's it. We can try to build this and let's run. We'll see if we have any errors or we won't. Okay. Sorry, NumPy, I wrote silly mistakes here. Okay, let's build. Oh, again, I need to keep more attention. Okay, let's build. And as you can see, it works. It gave us some kind of results. So it was dw, 2 results are db, so it's bias, and cost. So it's working. So for now it's fine, and later we'll put all to this propagate function our images, and you'll see everything will be much clearer for you. So for now that's it, and in this tutorial we defined a general learning architecture and defined steps needed to implement learning full model. I explained what is forward and backward propagation, and we'll learn how to implement them in code. In next tutorial we'll continue with optimization function, and you'll see everything will be step by step. And if you need to learn more, you can go to my text tutorial and check the formulas, everything, and so on. I'll try to write it more clearly, step by step, so it will be much easier to understand. And for now, that's it. Thank you all for watching. Subscribe my channel, like this video, so you will help me to grow my channel and to create more better videos. So thank you all for watching, goodbye, and see you in our next tutorial.